Okay, so I'm going to be looking at the May 2019 question 10. All right. So this one is a matrix question that came on the paper. You want to find the matrix product, right? This matrix multiplied by this. Okay. Now, in order to multiply a matrix, remember you must multiply row by column. All right. Now, in this case, we're going to say 1 multiplied by k will give me minus k, right? Plus, then 3 multiplied by 5 gives me 15, right? Then I'm going to take this row and multiply by this column here. So I'm going to get 4 multiplied by k gives me 4 k, plus h multiplied by 5 gives me 5 each, right? So that's the answer there. Now this matrix here, the order of this matrix was a 2 by 2 matrix, right? And we are multiplying this by a 2 by 1 matrix. All right. Now our final answer will simply be a 2 by 1 matrix, right? Which is what we have here. Now in part B now, they told us to find the value of h and k that satisfies this equation. Now you just worked out the product of this matrix here, right? You got minus k plus 15, right, on top, and you got 4k plus 5 each, right? That's what you got just now, and they're telling you that that is equal to 1 0. All right, so essentially what we have is a 2 by 1 matrix on the left hand side and a 2 by 1 matrix on the right hand side. These two matrices are equal, right? So therefore we can say on the top part that minus k plus 15 is equal to 0, right? Therefore minus k is equal to minus 15, and therefore k is equal to 15, right? So this is the first part. So we've solved for k. Next thing we need to do is to figure out what h is. So what we're going to do is to put 4k plus 5h equal to 0. So 4k plus 5h is equal to 0, right? And that will be 4. Okay, was 15 plus 5h equal to 0, right? So 4 by 15 is 60, plus 5h is equal to 0. So 5h equal to minus 60, and therefore h is equal to minus 60 over 5, right? Which will give me minus 12, all right? So h is equal to minus 12. Now, we have a next question here now. They want you to use a matrix method to solve this pair of simultaneous equation, right? Now, there are several ways to solve a simultaneous equation. We can use substitution, elimination. We can draw a graph basically, and there's a fourth method, which is a matrix method, right? Now, first thing we need to do when you're going to solve this as a simultaneous equation, we need to write it in a matrix format. To write it in a matrix format, all we're doing is taking the coefficient of the x and y's to come up with a matrix. So this matrix is going to be 2, 3, minus 5, and 1, all right? And we're going to multiply this by xy, and my answer should be 5, 13. Now, in order to solve this, the first thing we need to do, we need to take this matrix here, and we need to find the inverse of that matrix, right? So, the inverse of the matrix, the first thing we need to do is to find the determinant. So the determinant is simply AD by BC, which is 2 by 1. So it's 2 multiplied by 1 minus 3 multiplied by minus 5, and this will give me 2 minus 15, which will give me 17. So my determinant is 17. Therefore, my inverse of that matrix is going to be 1 over 17. Right? So it's 1 over the inverse. And we're going to write down the adjoint of the matrix. Sorry. And that will be, we swap the positions of the 2 and the 1. So this is 1 and 2. Then we have to put a minus sign in front of these. Minus 5. Right? So that is actually my inverse matrix. Right? Now, to solve this question, what we need to do now is take so this is my inverse. Right? I need to take the inverse matrix and multiply by both sides of my equation. So that will be 1 over 17 by 1 over 17 by 2, 3 minus 5 and 1 multiplied by 2, 3 minus 5 and 1, right? X, Y. One second, this shouldn't be a minus, it should be a plus here. That's a mistake. Alright. And then on this side it'll be 1 over 17, 2, 3. Wait, sorry, I have a mistake here. This should be 1, right? So this is 1, 3 minus 3. There should be a minus here as well, right? Sorry for the mistakes, right? And this is it should be 5 and 2, right? And this is 5 and 13. Okay, so now this is how we solve a simultaneous equation using matrix method. This whole piece here is going to give me my identity matrix, right? So my identity matrix multiplied by xy. So what is going to happen on the left side? This is all that is going to happen. You're going to end up with just xy alone. Then you're going to have to multiply this here by this, right? So when you multiply this out, essentially what we're going to get is minus 2 and 3, right? So you can practice working this piece out here. Alright, and you're going to get minus 2 and 3. So therefore x is equal to minus 2 and y is equal to 3. Alright, and that is how we solve using the matrix method. Now, this next one here, this part B, is a vectors question. So they told us relative to an origin O, we have two vectors. We have OA and OB. So OA, right, is 9, 0. So OA is 9, 0. OB is equal to 3, 6. And they told us that the points D and E, so that's this point here, this is D, and this is E. So they said, what they told us, AD is 1/3, AD is 1/3 AB. So AD, right? So basically we're going to use this information to find the vectors that they want, right? So the first one they want AB, right? So AB is this vector here, right? You're moving from A to B. So AB, right? We want to start at A and end up at B. So we can go AO plus OB, right? But the vector OA is 9, 0. So therefore the vector AO is the reverse direction. So it's minus 9, 0 plus OB, which is 3, 6. Right? So minus 9 plus 3 gives me minus 6. And 0 plus 6 gives me 6. Alright? So The vector AB is simply minus 6 and 6. Alright. Now the next one they want. Alright, so we know what, let me just write this down here so I won't forget it. So AB is equal to minus 6, 6, right? We know this. Now you want to find the vector OD. So OD, where is D? D is this. So this is the vector you want to find. You want to find OD, right? Now, to go from O to D, I can write that as OD. I want to start at O and end up at D. So I can go from, let's see, O to A, right? So I can go this way, O to A plus A to D, right? OA, we know what the vector OA was. OA was 9, 0. But what is AD? So AD is really 1/3 of AB, right? They told us that in the question. So that is 9, 0. And we just worked out what AB was. So this 1/3 of minus 6, 6. So this is really 9, 0 plus, right? So this is a scalar multiplication of a vector. 1/3 by minus 6 is minus 2. And 1/3 by 6 is 2. So this gives me 9 plus minus 2 will give me 7. And 0 plus 2 gives me 2. So that is the vector OD. Alright? And the last part now, they want us to find the vector BE. So you want to find the vector BE. Right? So where's BE? BE is coming down here. Right? So BE is simply equal to BO plus OE. Right? So you're going to go from B to E. So therefore I can go from B to O and then O to E. Right? So what is BO? So BO is simply the reverse direction of whatever OB was. Right? OB I think was 3, 6. So BO will be minus 3 minus 6. Alright, let me just double check down there. Yeah, that's correct. Alright, plus OE. But what is OE? OE was 1/3 of OA. Right? So that is minus 3 minus 6 plus 1/3 of OA, which was 9, 0. Right? So again, this is minus 3 minus 6 plus, this is a scalar multiplication here. 1/3 by 9 is 3. And 1/3 by 0 is 0. So minus 3 plus 3 is 0. And then minus 6 plus 0 is minus 6. Alright, so the vector BE is simply 0 minus 6. Alright.